Well, I'm talking about love of Jesus Christ. And I'm talking about peace that Jesus gave. Listen, because He let us life and He took it again. And He gave us a victory. Well, I'm talking about peace. He gave us peace and love. Well, I'm talking about joy.
Good day and welcome to today's lesson of Mensuration 1. Okay, and you can check out our previous videos where we treated functions, variation, and several other topics in mathematics. So today we are going to look at Mensuration 1, which involves the finding area and perimeter of parts of a circle, and also maybe area and perimeter of plane figures, right? Plane figures are the rectangles, the triangles, the rhombus, parallelograms, and the rest. Okay, so we will start from parts of a circle, then eventually we will get to finding the area and then the perimeter of plane figures. Okay, so let's start from part of a circle. Part of a circle. So now I believe right from early stages we know what a circle is. Okay, a circle is just bounded by a complete arc, which is called circumference, which has what? A center, right? So if we have a center here and then we bond it by this, then this is what we call a circle. The circle, the outer part is called the circumference. Okay, this is called the circumference, right? And then this is then the center. Maybe I denoted as O, as A, whatever. Okay, so the center can be given to you in any form. All right. Now, if you have a circle, then for it to be a circle and not an ellipse, or for it to be a circle and not any oval shape or anything, one very important feature of a circle is that at any point, when you rule a line from the center of this circle to any part of the circumference, this line should be the same as if I ruled a similar line to this part, any part of the circumference should be the same. That is one characteristic of a circle. So the line you pick from the center of the circle to any part of the circumference is called the radius. Okay, it's called the radius. So this line is called the radius. So if it hits the part called A, B, C, and this is the O, then we say what? OA, OB, and then what? OC are all what? Radii, because they are a plural form for radius is radii. So this is a radius. Collectively, they are all what? Radii. Very good. So from the center to the circumference is called a radius. Now, if you have this one here, starting from C, and then another radius continues from this center to hit the circumference of the circle over here, say A. Okay, then this now becomes like a straight line starting from this part of the circumference to this side, right? But then this line has passed through the center, so it's almost like two radii that are on the straight line. Okay, so anytime you have two radii on the straight line, then that line is called a diameter. Okay, so a diameter is simply a line starting from one part of the circumference to the other, passing through the center. Okay, so that becomes what? A diameter. So then we say AC is what? A diameter. A diameter. Okay, very well. Good. So these are parts of what? This circle. Now, there could be another line ruled from, let's say, this part of the circumference to, let's say, this other part. So from here to here, let's say it's all D to E. Okay, so this is rule from D to E. Then we will call this one a chord. Okay, we'll call this one a chord instead. So the question will be, what is the difference between this diameter and then the chord? The difference is where it is passing. The chord is simply starting from any part of the circumference to another part, anywhere in the circle, with the exception of what? The center. But the diameter itself, it starts from what? One part of a circle to another part, but it's passing through the center. So diameter is more like a chord in quotes that is just passing through the center of the circle, or two radii that are brought together on a straight line. Then we say that is what a diameter. So a diameter will always divide the circle into two equal halves. Very well. So this is the very first part of what this circle. Now, if you start from here, point B up to point C, then this part of the circumference from B to C, okay, is called an arc. So an arc is simply a part of what? The circumference between 2 points. Okay, so an arc is simply a part of what? The circumference. So then this is bonded. This will be referred to as an arc. So this time around, we have this shape, say O to B, and then B to C, and then C back to what? O. So you see this shape here, from O to B, B to C, and then C to O. We will call the entire shape over here what? A sector. We call it a sector. Okay, so a sector is simply the part of a circle bonded by two radii. So this is one radius, another radius, and an arc. So a sector of a circle is simply bonded by two radii and an arc. Right. So we can liken sector to a slice of pizza. Now when you buy a pizza, you have the full pizza, okay? And then you pick a slice. You see the shape of it? It's almost like this. This with a down like that, okay? This is what we call a sector. Same shape as this. So this is one of the radii. This is also a radii, and then finally this is an arc. So when you pick a slice of a pizza, you are applying mathematics. Yes, mensuration 1. And that is actually what? A sector you are picking up there. Okay? Fine. So if you decide to divide a sector horizontally, that's point to point, then let's say you decide to draw a chord starting from this point here to meet this other point over here, C. Then we say, okay, the remaining at the down here, the top is going to form a triangle, but the remaining down part is neither a semicircle, nah. So this one, the remainder, then we say, okay, this part of it, that is from B to C, like this, will be called a segment. Okay, the shaded portion will be called a segment. A segment. So the arc is from here all through to this, and then the segment is what? The base portion of a sector. Okay. Now, if I clean these lines in there, then we have a new sector introduced. Okay. Now, you remember that we said that the definition for sector is that it's bonded by two radii and then an arc. You could agree with me that if an arc is any part of the circumference, then from B up to C, this place, is also an arc because it's also part of the circumference. And then from here to O, that is from here to the center, and then from this place to here. So meaning that this shape that is up here, this shape that is up here is also a sector. Okay, it's also a sector. So if I give you a question, how do you identify whether I'm saying I'm referring to this sector or this? Okay, so then we use major and minor to get the difference. Major and minor. So minor is more like the small one, and then major is more like the big one. Okay, so minor and then major. Minor and major. Okay. So now that we know the various parts of the circle, now let's try to find the area and perimeter of those shapes, the sector, the segment. Okay, the sector and the segment. Alright. Now we need to group them into two, the minor ones and then the major ones. So minor arc, major arc. So let me clean this part here. Then we'll start looking at how these things are placed. Okay, so let's start with the minor sector. Keep saying arc. Minor, let's start with the minor sector. Right. This minor sector here, you know, if I have two lines meeting at a certain angle, then we can actually get the angle between them. And so let's call this angle theta 1. Okay? And then this one too is also a sector. It's also a sector. So let's call this also theta 2. Right. So if we should sum the angle, all of them are forming around this point, then we know that the angle of what? Around a fixed point is what? 360 degrees. Okay, angle around the fixed point is 360 degrees. Therefore, what we are actually saying is theta plus theta 2 is going to give us 360 degrees. So it tells you that, okay, then theta in itself is theta 1 is a part of what? The total angle, and then theta 2 is also what? A part of it. Are you okay? Very well. So if I give you any of this and I ask you to find the other, you can determine that angle by using change of subject. So let's say I'll give you theta 1, but the sector you are working for will request that you use theta 2. You just send theta 1 to this side, and then you can get what you want. Very well. Or maybe if I ask you to find theta 1 and I give you theta 2, you can do that as well. Okay. So now let's pick the minor sector, that is B to O to C and then back to B. Then this one here, we need to find, let's say, the area of this. The area of this. If, let's say, there were no lines over here, then the whole area of this, the area of this whole circle that is here, is always given as what? Pi r squared. That's the whole area, right? But I'm not taking the whole circle, I'm taking this part of it. Okay? And it's not half. It's like some part is here, some part is here. So it's more like it's forming an angle. So you can see that the sector will be a fractional part of the area of the total circle. Okay? So how then do we determine that fraction? Okay? You can just use the angle. So we know that the total angle for the circle is supposed to be 360 degrees. So then the fraction will be the amount of angle this is taking out of that 360 degrees. That will give you the fraction. Okay? So then if you want to find the area of this minor sector that is here, then you are going to use theta 1. So theta 1 divided by the whole angle, which is 360, times pi r squared. So it's theta 1 divided by 360 times pi r squared. Okay, so that is how it's going to be. Theta 1 over 360 times pi r squared. That is the area. So any one that will be given to you, you just use it and then fix it with your values. We will come to the numerical example, but for now let's generate our formulas we need to use. And you know, area and perimeter, they express a little bit of twin behavior. Okay, so anytime you find area, you must find perimeter as well. So if then we want to find the perimeter of the whole sector, the perimeter of the whole sector, then perimeter of the sector is going to be this. Now we know that perimeter is the distance around a figure. So like this marker, the distance around it is going to give me the perimeter. So I will add here, plus this side, plus the top, like that. I'll add all together, and that gives me the perimeter. So then, same with the arc. Let us remove this slice of pizza or the sector out. So we have this here, and then that. So this is our sector here. So this sector is bounded by what? A radius. You can see this is a radius. So this is a radius. And then this part here is also another radius. So this is also a radius. Then from this shape to this place here is what? A part of the circumference. So how do I get this part of the circumference? Then we can say that, okay, this part is also called an arc. So more like the perimeter of what? A sector, of a minor sector over here is going to be this first r, so r plus another r. Radius are the same, so r plus r, then plus what? The arc. So plus the arc. So r plus the arc. That's going to give me what? The total distance around it. But then we are saying that the arc is also a part, a fractional part of what? The circumference. So just like we say that this sector is a fractional part of the area, then arc will also be a fractional part of the circumference. So you see what I'm trying to imply. So it means that if you want to find the perimeter of what? Sector, it's simply going to be this r plus the other r. Then the arc is giving us the fractional part of a circumference. So theta over 360 times the circumference, 2 pi r. Theta over 360 times 2 pi r. So if they ask you to find the length of what this arc over here, then that is what? That is it. Theta over 360 times 2 pi r. So anytime here length of an arc, theta over 360 times 2 pi r. But when you are dealing with the perimeter of the sector, then it's not only the arc, but there are two radius bonding the same shape. Okay. So finally, we can now conclude that the perimeter of what? A sector. The perimeter of a sector is just 2r plus theta over 360 times 2 pi r. So that's going to be our final formula for finding the perimeter of a minor sector. Sorry. Right, so I believe by now you've been able to establish this and then also this. So now let's take an example here. If I give you a shape like this and I tell you that the center is this and then the radius is 8 centimeters. Okay, the radius is 8 centimeters, and then the theta here is 60 degrees. So you should find the length. Okay, find the area of what this minor sector. So you have been given theta, you've been given r. If you know these two, no stress. So there is no stress here. So all you need to do to find the area of this minor sector is to call this formula here. We say that the angle given to you for that particular minor sector over the total angle times what? Pi r squared. So then the area in this case is going to be what? 60 over 360 times pi r squared, which is pi times my radius is 8. So times what? 8 squared. Okay, so you have 60 over 360 times 8 squared. So the area is just going to be 1 over 6. Okay, 1 over 6 times what? Pi times 8 squared is 64. Okay, 8 squared is 64. So basically, when you punch this on your calculator, you can finally reduce it so that you get 64 pi over 6. So when you do 64 pi over 6, you see your calculator, then you can leave your answer in what? Decimal. Okay, and leave your answer in decimal. So then you look at the SI unit of the radius. If it's in centimeters, then my answer will be in centimeter squared. If the SI unit of the radius is meters, then my answer will be in meter squared. If it's in kilometers, it should be in kilometer squared. Okay, so look at the SI unit of the radius. Then we use it to get the unit we are going to use for the area. So same way, if I am using this same question and I'm supposed to find the perimeter of this, then I'll just rely on this formula. So let's say we're doing the same thing for the perimeter, using the same very values we have there. So you just get to pick the perimeter. So we said that the perimeter is given as 2r plus theta over 360 times what? 2 pi r. Okay, so theta over 360 times 2 pi r. Now we know the variable value, so we just put it in this equation. So you have 2 times what? 8, which is my radius, plus 60 over 30, 360 times 2 times pi. So 2 times pi times what? The radius, which is 8. So we just follow whatever you have there. Okay, so eventually you can just reduce this into being 16 plus 1 over 6, then times is 16 what? Pi. So you are having 16 plus 16 pi on 6. Okay, so you can just add this on your calculator to get the value. And then you have your centimeter. Okay, so having both perimeter and area in our graphs is simply a very good and a major progress. Okay, now if you are done with minor sector, these are the only questions they can ask you. Minor sector is either find the area when they're giving you the angle and then the radius, or find the angle when they're giving you the area and then the radius, or find the radius when they're giving you the angle and then the area. So all is what? Change of subject. All this is our change of subject, nothing more. Okay, nothing more. So then we are having this whole situation. Alright, so when you are done with minor sector, all you need now is what? Major sector. Major sector. So there is no much difference between the minor sector and then the major sector, because I told you they are all sectors. So the very behavior of sectors is the same thing both of them exhibit. Just that when we are looking at the major one, the bigger one, this is my R and then this is my theta. Okay, just that when we are looking at the major one, then we say that okay, this whole thing around here is 360 degrees. I told you. So if we are looking at the major, we'll be using the bigger theta, the second one, theta 2. Okay, so what is theta 2? You can see that theta 2 is actually what? 360 minus theta 1. So they will give you the angle over here, and it still asks you to find the major sector. But all you need to do is that, knowing the angle here, then means that the remaining now belongs to the major sector. So in terms of major sector, now is going to be major, and this one is now going to be what? The area is going to be 360 minus theta. Okay, so that's all that will change. The formula will change, only the angle. So this one will change from theta to 360 minus theta. So if, like the previous example, our theta was 60, over here for major it would have been 300, because it would be 360 minus the 60. Okay. And then same with the perimeter, nothing will change. The only thing that will change over here will be the theta, which will now change to what? 360 minus what? Theta. And that is the end of the major sector as well. So that's the end of what? The major sector. So there is no difference between major and minor sector. There is no major difference. The only difference is just the angle. Okay. So if here is 60, here will be 300. If here is 140, here is going to be what? 220. Like that. Just keep subtracting the smaller angle from 360 to get the angle for the bigger one, which is what we refer to as the major sector. Okay. So they are very part of what? Sectors, and these are what you need. Very well. Now, in sectors, I told you another part of a sector is a segment. So another part of a sector is what? A segment. Okay, it's a segment. So a segment then will be a part of what? This sector. Okay, it will be a part of this sector. So we have let me clean this. And let's shoot now segments. So let's pick our sector. This is the shape of our sector. This. Okay. And so when we cut here, then we say this is our segment. So we've taken this segment out, and we are trying to now find the area of the segment. So you now see that a segment plus a triangle brought together is what is going to form a sector. Okay, is what is going to form a sector. So if you want to form the area of what? A segment, then you can clearly see that, okay, if I should add a segment and a triangle, that's what will form a sector. Then if I need only this part, I can take off this from the main one. I say the segment here is a part of what? This sector. And when I maybe draw this line and then disintegrate this, you are saying that you are having a triangle and then what? The segment itself. So if I want to find a segment, because it's neither a semicircle, it's just a segment, right? It's just a segment. A semicircle is bounded by what? The arc and then the diameter, right? But this is not, so we have to find a way of getting it. So if we know that the area, so let's say a segment now. So a segment. Okay. So if we know that the total area of a sector is this, then if we are looking for the area of a segment, then we know that we must have the area of the sector minus the area of what? The triangle. So we are going to do that, the area of what? The sector minus the area of the triangle. Okay, very well. So if we do this, then that's it. We know that the area of the sector, we know if this is a minor segment, then the area of the sector that we'll be using here will be theta over 360 times what? Pi r squared. Okay, so that is established. Then minus the area of the triangle. Now there are two ways you can approach this. Either you find this side using the shape here, when you divide it into two, and use trigonometry and all that, and come out with what? How to find the area of that particular triangle you are having there. Okay, but why do you stress yourself? After you do that, all will be reduced. Okay, all that will be reduced to what? Half r squared sine theta. Okay, so half r squared sine theta. So if you are looking for the area of the triangle, then you can use half r squared minus sine theta. So looking for the area of the segment, then you are supposed to use this formula that is here. Okay, so referring to our numerical example where we were having our theta here to be 60, then if I want to solve this and then our radius to be 8, then it's just going to be 60 over 360 times pi times 8 squared. Okay, all that minus, so you can put this in a bracket if you want, all this minus half times 8 squared, the sine of the angle, sine of 60. Okay, sine of 60. So then that is going to be your answer. So all these things are just calculator work. Okay, it's calculator work. But just know how you can generate these formulas, or maybe if you can learn them, it's going to assist you. Okay, if you can learn them. Very well. So that is how this is. So normally they will ask you the area of the segment, and then you have to get this. It's been a very nice journey treating the part of a circle. Like I told you, this here is only the major questions they can ask you, or the major information you can get from the part of the circle. Finding the area of sectors, perimeter of sectors, or area of segments, and all that. Okay, and each of them have gone through how to generate them, and then that. So these parts is actually formulas. Keep the formulas in your head. Maybe you can wake up, learn them a bit, sleep, solve several examples, and I believe you are going to be fine. If you need any further clarification or assistance in terms of trying to understand this very first part of mensuration 1, which is the part of what? Circle. Okay, and if there is any comment or suggestion as to how we can further improve this video, you are always welcome to bring your various suggestions. Okay, the administration and management of King David College always welcome you to any suggestions you have. Okay. So I will see you in the next video where we treat the area and perimeter of plane figures such as triangle, rhombus, rectangles, and the rest. So watch out for that video too as we conclude the whole lesson under mensuration 1. Thank you. Bye-bye.
He gave us peace and love. Well, I'm talking about joy. The joy of the Lord is my strength, because it made me so happy in the Lord. Listen, because it took all the walls of the vision, and it brought me closer to my God. Yes, it makes me go wow. H-A-P-P-Y, H-A-P-P-Y. Yes, my Lord is so kind, so kind to me, because my Lord is so good, so good. Well, but I'm